Ahí sales. ¿Quiénes están ahí? No, todavía no. No hay nadie.
Hello, Jaylene. Nice haircut. You were talking about number 1 first, whether the given table indicate a probability distribution or not. In the meantime, I try to make copy and then post on the whiteboard.
I don't see him here. Oh my god. How long is this for? Like till 1:40?
Yes.
Yeah.
What?
I know.
Nah.
We on page 41, right?
Yeah, page 41.
Yeah.
Yes.
I feel like I'm getting homeschooled. This ain't good.
Right.
Nah, Anita's face got me weak. Nah, these faces is that they mad serious.
I can hear you.
I know you can hear me.
I could swipe up in this app and still be on this or no?
What, you mean like,
Like go on something else real quick or no?
yeah,
You tried it?
yeah.
Oh, it's like FaceTime.
Naomi Jeffries.
That's me.
Kyla, come back.
Wait, I'm doing the work. I hate probability.
Don't turn around like I had to pay for you.
Come on. It's hot in here. Oh my god.
I hate probability. Now, how are we gonna be taking tests and stuff online?
Everything will be take-home exam from now on. So I will notify you when I give you take-home, but there's no group quiz though.
Okay. There's no group quiz?
Because I cannot make a group.
Yeah, that's right.
hate probability.
Okay, then let's start going over number one, the first table. So is it probability distribution or not?
You asking us?
Yes.
Mhm.
I
Yeah, I
honestly
think.
don't know.
Yeah, I don't know. I hate this.
Okay, so first of all, combine all these, please.
Combine it. How?
Yes. So 0.3 plus 0.25 plus 0.25 plus 0.15 plus 0.05.
It equals to 1.
They equal to 1.
Mhm.
It should be
So let me read
25.
for you.
25.
Yeah, so please combine all the probability value and then make sure you will get 1.
Yeah, they are
Then,
equal to 1.
okay, then it is the probability distribution table because it is total become 1.
Oh, okay.
Okay.
Wait,
Otherwise,
so
it
when
is
it equal up to 1, that means it's a probability distribution.
yes, that's correct. Yes. Okay, then what about the second table here? So
Not
same
gonna equal
way,
to
you are
1.
combining all this value.
Oh, it's not because it's more than 1.
You sure? What did you get? The sum.
Because the first one is already 0.130 something.
That doesn't mean nothing.
Wait.
So when you combine all
Wait,
this
I thought it's
value,
1.35. Never mind.
1.35,
I got 1.862 for the sum.
1.862.
Let me see what I get.
So which value is correct then?
Wait, I'll double check. I'm not sure about mine.
Wait, what happened to the boy in the class? The oldest boy that was in our class. He's on this? Oh no. Kiara, you know what I'm talking about, right?
Yo,
He was
No.
here, yes. He was here on Monday, but he's not here yet. I think he's late.
576.
So did you get, yeah,
wait.
I got 1.3.
I got
Yeah, I got
1.576.
1.576. Yeah, I got that too.
okay, then let me check.
Wait, let me do
I
it
got
over.
1.576 now.
Yeah,
Yeah, that's it right here.
1.576.
So,
correct answer.
1.576.
so it's not a probability distribution, right?
Yeah,
Exactly. So it's not because
it's not
the
equal
sum
to
is more
1.
than 1, it is not.
So what happens if it's less than 1?
Great
It's
question.
not, right?
Yeah, so let's say we have maybe x and px value. And now this one is maybe 0.05 and then 0.12 and then 0.36. Then definitely sum, what's this sum by the way? 0.05 plus 0.12 plus 0.36. It only gives us 0.53, so it's not probability distribution either. Okay. So to become a probability distribution, so each probability value must be between 0 and 1. That's one condition. And then the total sum must be equal to 1.
1.
Okay. So you know what this means, right? This means sum. Okay. So
Yeah.
you combine all px value, they equal to 1, then that is correct answer. But here, the most of the case, when you add px value, then it won't be exactly 1. Sometimes you may get 0.999 or
Do you round it?
1.001, something like that.
Can you round it?
Yeah, because we are rounding so that your answer can be 0.999 or 1.0001, but they are really close to 1, basically. So we can accept them and then make approximately make equal to 1.
Okay.
Okay, so whenever you do probability distribution, I recommend you better round 1,000th digit, 1,000, so that even though
Okay.
you make a rounding mistake, you know, your answer still became correct, okay?
Okay.
Yeah. Okay, then now, number 2A. So please double check this value is same as your lesson note, because the last time the value was incorrect. Is it correct
Yeah.
value?
It's the
It's
same.
correct.
Okay.
Okay.
So now here, so I can say dog, which is the x, and then household that represent frequency value. So now I'm gonna give you some time. Please find out px. I gotta make some. So you guys can talk to each other as well, but please find out how to determine each category of probability.
Hey, I don't know what happened to my phone. Oh, never mind. Nah, it said something weird.
Nah.
It said leave the class. I was like, yo, what's going on?
Yeah,
How you
I got
find
a
PX
whole-
again?
Yeah.
That's when
I
you
was just
That's
you
great question. So who can explain how to find
around.
px?
So you find the sum of the second column, and then you take the number and divide it by the sum.
huh?
Huh?
Wait, what? Say
So
that again?
1471 plus 425 plus 168 plus 48 plus 29 plus 14.
Okay.
Yeah,
And
you
to
got
find the P of x of 0, it's 1471 divided by the sum.
So
1471 divided by the sum.
Divided by 2155.
Oh, all right. So you just do
25.
all of them like 425 divided by 2,155, right?
Right.
And just keep going. I don't know.
Okay, then let's complete this table. So what did you get px value for first blank?
68.
0.58?
68.
68,
Yeah.
okay.
Mm-hmm.
Second one,
0.19.
19. Third one,
0.07.
07.
0.02. 0.013.
And 3, and then
0.0064.
006.
Yes.
Okay,
But when I add it all up, it's 0.999. Is that okay?
yeah,
Yeah,
that's fine. Yes,
one.
because we rounding. So you know if you got 0.99, then I can say 1% error. But 0.999, which means 0.1% error. So compared to 1% and 0.1%, this is much smaller, so we can ignore the error. So we just assume this is equal to 1. Make sense?
Yes.
Okay. And now, next column is we are finding each x value time px.
Which one is the x value though?
So x is this column.
So
I know the first one answer, which is 0.
0, yeah. The other one is 0.19.
Oh yeah, 0.19. And then I get 0.14
Yeah, 0.14.
and 0.06, I guess.
I just copy with y'all. I'm not gonna solve it.
I'm just gonna copy it. I just do it on
Yeah,
my own.
they're going so
Cause
far.
they're gonna math fast.
Yes.
The other one is 0.052.
Oh, 0.052.
Yes.
But for the third one, I got 0.66.
I mean, this one?
Yeah.
0.66.
Yeah.
Okay, 3 times 0.02 though.
Oh wait. Yeah, 0.
I think it's because she has a 3-digit decimal, and over here you
Oh,
only
I
have the
see.
2-digit decimal.
Okay, so then 0.066. I like that more. Okay. And
The
now,
last one is 0.03.
so 0.03. Okay, combine this column, please.
Combine it, like add it.
Yeah.
I'm mad confused. Didn't you just have 0.066 for the PX on the last one?
Wait, huh?
I'm mad. Never mind. I just copy what you write.
So for the last one, it's 0.006 times 5. 6 times 5 is 30. That's why it's 0.03.
Nah, I could have sworn for like the last one for PX, for the last column for 5, he had 0.066. I
No,
don't know. I probably wrote it wrong.
0.006.
Yeah, never mind. I had it wrong.
So if you combine this column, then what do you get?
I got 1.158.
1.158.
Yeah.
Okay, so now that's our mean value, right?
You.
So now is that population mean or sample mean?
Say that again.
Is it population mean or sample mean?
What's the difference between the two?
Yo.
Population you are indicated as mu, sample you indicate by X bar, and you know the population sample relationship, right? So sample is part of the population. Now this data represent population mean or sample mean?
Sample mean?
Sample.
Actually population.
Why?
Yeah, so getting to population data, okay? So population mean equal to 1.158.
I'm lost. Not even gonna hold you.
Okay, here,
Yeah.
so like this, we just, now we know this is percentage value for this X value here, right? So X equals 0 means 0.68, X equal 1, 0.19, 2, 0.07 like that, right?
Yes.
Now, I'm gonna delete all this frequency value. Okay, which means we don't know the actual frequency value anymore. Good?
Mm-hmm.
And then you see this table for the first time. Then can you guess number of data?
I don't know.
If I see this table for the first time, I may say, oh, X equals 0, maybe 68 people say, yes, and then 1, 19, 2, 7. 3, like 2.7, 4, 1.3, 5.6. That will be easier way to say that. Or I can make even 1,000 people then 680, 190, and 70, 22, 13, or 6. You know what I'm talking about? Hello? It's really important why we determine PX value's population value. It's looking at PX value, we cannot determine number of data. So there's so much variation. You know, like I'm saying, I want to say 680 people, 190 people, 70 people like that. But 680 out of 1,000, 6.68.
Professor, we are in the old one.
Oh, hell no.
Excuse me?
We are in the old one. Old Zoom.
So
Come on, don't come on here chatting. We don't got time. We was learning.
Professor, they said they in the old one.
what do you mean?
I don't know.
What do they mean they in the old one? How you still
they were
connected
in
from
old-
Monday?
old
Like
room.
what?
Okay. Sorry. Yeah, now from today we all switch to BMCC server. That's what happened anyway. Sorry.
Oh, we were in the other one. Yes, we were. We
Sorry
were
about that.
Oh shit.
Yeah.
Anyway,
Leave
that's
this
the
shit.
reason it becomes population because we cannot justify number of data anymore. Okay. Anyway, if you still get confused, then I already posted last week lecture, so we can review that together later. Okay. And now the last column becomes x squared times px.
What is this? Okay.
41. I don't got
Page
patience for
41,
this.
number 2A.
Professor, I'm sorry I'm late. We were waiting on the other. I'll tell you later.
That's why I emailed you.
Oh God. I told them the code. I hope they're here. I don't know if they're here yet.
Yeah, they're
But
here.
we were waiting since before 12 to know.
I told you.
Zero. And then
Wait, how we get the last column? What we do to get
What
the
page is this?
huh?
We are doing page 41, number 2A.
Thank you.
31 or 41?
31?
41.
X squared.
31. Number
31 or 41?
41.
41.
4, 1.
Thank you.
Oh my gosh. Naomi, that's your little cousin crying?
Oh yeah, y'all hear that?
No, we can hear her.
Oh my bad,
Okay,
y'all.
so let's
So we
continue
at
on
school
the
right
last
now.
column here. So what's the x squared times px for first blank?
First one is 0.
So there will be 0.
I'm in class right now.
And first,
0.68.
this one become 0.19.
Yeah.
Yeah.
And third blank become 2 squared times 0.14.
0.28.
28?
Yes.
No.
Yeah. It's 2 squared times.
Oh yeah, that's you're right. Sorry.
0.07.
28. Now 9 times
0.18.
point
Which is going?
18.
18.
Yes.
Oh, we switched to 0.022 though.
Wait, I'm confused right now.
Because so mostly we round at the time 100th digit.
Okay, 0.192.
Yeah, 0.198. And then
16. 0.208.
208.
Then 25. Wait. 25 times 0.15.
0.15. Okay. Please combine this column.
I got it. Is it 1.026?
1.726.
No, 0.26.
1.026.
0.026.
Okay, 1.026.
1.0.
Okay, now we are ready to find the variance sigma square. Sigma square is equal to this one, 1.026 minus this one square. 1.1.
What is that, Professor? Is that a what? A R?
It's wrong number, I think.
This is the variance, so sigma. So like this, or sometimes you can do it this way too.
Oh, okay.
The sigma.
Okay.
That means the 1.158. What's this number?
This is the sum of x times px value.
No, it's wrong.
It is wrong?
You have to check. It's definitely wrong. No one will bigger than 1.
Okay, let's check. Then.
0.19.
Yeah, I got something different too.
0.14
For the PX column, right?
666.
The
I got
x
something
times
different for that one
column.
too.
0.052. 0.03. I got 0.956.
I got 0.307.
I got negative 0.
Negative?
What? Negative?
No, here. So Bean just point out this value is incorrect, so we need to double check this one.
Wait, what you got? Wait, what I got?
We all got different answers.
0.19 plus 0.14 plus 0.006.
I got a negative.
0.48.
How you getting a negative if you adding positive numbers?
I got 0.478.
Yeah, that's what I got.
0.478, not 1.158.
So
Yeah,
then the value is incorrect, so should be 0.478. Which means our mean value also switched to 0.478. So that also becomes 0.478 square. Okay, let's make sure this value is correct then.
Yeah, that one, I think it's correct.
Okay.
Yeah, that was correct.
So now, if you calculate, then what do you get this one?
You have 0.797.
0.797.
516.
So 516, so you can round 0.798 then, right?
Yeah.
So that's our variance. Okay, then now the standard deviation. So sigma equal to square root 0.798.
I got 0.8933.
0.8933. Yeah. So now we can round up 0.983. Okay. So we found the mean value 0.478, variance 0.798, and the standard deviation 893. Okay. I really hope you understand how to find those values because yeah, it will be on the exam number 2, even though it's take-home exam. So you don't know what to do, then you may get a hard time to complete it. Okay. Any question about number 2A?
No.
Okay.
I have a question.
Yes.
Why did you erase the household number, like the
The
numbers?
reason is I wanna emphasize why probability distribution. Just we are talking about population data, not sample data.
Okay, thank you.
Yeah, and then maybe at the beginning of the semester, I told you that the reason we are finding the relative frequency value because we want to switch sample data into the population data. I hope you remember my comment. Okay, but that's what we are doing now. So PX represent actually the relative frequency. So we are dealing with the probability distribution, which means now we are talking about population instead. Okay. Okay, I think that's all our homework the last time. And then now what we want to do. So by the way, lab 2 already assigned and then lab 3 hasn't been assigned from Monday. So you better do it as soon as possible.
Lab 3?
Yeah, so we assigned until lab 3 so far. Okay. And then because I cannot meet you face to face, so please make everything as a Google Doc so I can give you my comment immediately. Okay.
Okay.
Now we are doing lesson 8.
Lesson 8?
So we're doing page 44.
Page?
44. So first thing we talk about normal distribution. So this topic, the concept is a little bit complicated though, but you will have a really fun, compared to binomial probability or other topic. This one is really interesting.
Oh my God, what's that noise?
It's
Okay.
lesson 9 though. It says
Now,
lesson 9.
normal distribution. A normal distribution is a continuous probability division random variable x. The graph of a normal distribution is called the normal curve. A normal distribution has the following properties. Number 1, the mean, median, and mode are equal to each other. So which means we assume the central tendency value are equal to each other. Now, second condition, normal curve is bell shape. So like this picture looks like bell shape here, right?
Mm-hmm.
Yeah, and then number 3, the total area under the curve is equal to 1. That's the really important point here. Okay, so what happened? So it's really important. So let me. Okay, now the third one here. The normal curve approaches but never touches, which means, this line, you keep on going on the left side forever, and the right side also forever, but it never across the axis.
Never meet.
Okay, that's what this means. And this part is really important when we talk about the central limit theorem. So it should be really clear. Now, between mu minus sigma and mu plus sigma. In the center of the curve, the graph curve downward, the graph curve upward to the left, mu minus sigma, and the right of mu plus sigma. Do you know what this means?
No.
So from here, it's going to up, right? Now it's going down. That's what this means. But condition E is not important. But the one thing is, please remember that they are equal distance. Do you see my mouse here?
Yeah.
So from the center going to left sigma or right sigma, they are all equal to each other. And you know what the sigma means, right?
The variance?
Sigma means standard deviation, especially population standard deviation. Okay. Yeah. Now, then.
Standard deviation.
Yes, here. Look at this A and B. It's open discussion problems. Which normal curve has a greater mean? Which normal curve has a greater standard deviation? So think about that. Between A and B, so you are thinking about these two problems.
So the one that has a greater mean is A.
Why? What's the reason?
Because it's like up, it's high.
Elevated.
Yeah.
Really? Okay, then so let me just switch to my whiteboard here. And not this one. So what about this then? So I'm gonna draw the random two normal curve.
Wait, this an example?
I mean, I'm just drawing random two curves, so I'm gonna double check whether Khadija actually comment is correct. So this time I'm gonna make it this way. The other one is okay. So I'm gonna say this is A and this is B. Which one has the greater mean value?
B.
A.
B?
A has green mean value.
B. Because the middle, the highest point is at a higher value. But A has the highest point at between 10 and 15, which is lower than between 20 and 25.
Okay, so.
But on the paper, B is lower.
No, I just made up. So it's different from textbook question here.
I think B has the greatest between 25 and.
So textbook question is. So this is A.
Yeah. Because I'm at class right now.
There was B. And then Khadija just said that A has the greater mean value because it's taller. So that's why I want to double check. Okay. So now this case, I want to say A has greater mean value. I agree with that. But her point, I disagree. So in this case, B has the greater mean value because of the.
I was going to say that, and then I was going to say that B has the greater mean, and A has the normal curve or whatever.
B. Okay. Now, so among this question here, this question anyway, we're doing the same question anyway. So which one has greater standard deviation?
B.
A. I said A. Mean value is B.
Wait, say it again.
So which one has the greater standard deviation?
B.
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 Go on with A.
Yeah.
Because in the book it says the mean is the middle point.
Yeah.
And the values they gave us are on the bottom. So
But then you just tell us that to find the standard deviation, like something going left to right got to be equal or something like that.
Oh, we're talking about standard deviation? I'm sorry.
Yes.
Oh, yeah, then A.
A is greater standard deviation?
Yes.
What's the reason?
Because then you just say that. Then you just say like when it's in the middle and then you go left and then you go right.
No. Should be B still, right?
Listen, I don't know.
It should be
I think it's B because
It's
B
B
has
because
more
it's
distance.
20.5.
Yeah.
Yeah, and B has more
No,
distance.
20.5 represent the mean value. You know, when we analyze this bigger or smaller to standard deviation, mean doesn't do anything. Okay, so to make understand easier, I'm gonna make exactly same mean.
Oh, you have to find the standard.
So first, A curve, and then B curve here. So as you see, I made their mean value is the same, right? But based on that, we only want to analyze which graph has the greater standard deviation.
B.
B?
I go B because it goes further.
Mhm.
Yeah.
Kiara, what do you think?
I don't know.
You know, I think. So Lorraine, what do you think?
I said B because it goes further.
Oh, that's a good point.
That's what I
Kara?
get. Because earlier when you said it could have been A, I thought it was because like more up there, but then B has more of a distance. So I guess that would be the greater mean. I'm not sure. I just feel I'm weary. I'm guessing at this point.
Okay, your explanation is really great.
Thank you.
Okay, Mooney, what do you think?
I don't know.
You don't know? Okay, Jaylin?
Oh, no, I'm not sure.
Not sure? Okay, then I'm gonna invite Lorraine one more time. Explain one more time, please.
I said that earlier when the professor said A was greater mean, I thought it was because it was like maybe more taller, but then I noticed that B has a further distance. So I'm guessing with the greater mean, with more of a distance, I'm guessing it would be B for the greater mean.
I mean, you mean standard deviation.
Standard deviation.
So as you see, B covers more area here, right? So you see here. So simply, B kind of cover from here to here. A simply cover maybe around here to here. Make sense?
Yeah.
So because total area, B graph is wider compared to A graph. So B has the greater standard deviation. Kiara, yes?
Understand.
Okay, so now we can conclude that the bigger the standard deviation, so this means the standard deviation, by the way, then graph is shorter and wider, and smaller standard deviation, then graph is taller and thinner. Okay, so that's the property basically.
Professor.
Yes.
What's the M? It says graph M.
Where is M?
Is that like a sign that says graph M shorter and wider.
I think that's is.
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 Okay.
Okay, so now normal graph here, so I'm gonna just make one scenario here. So maybe Kiara and then Anita.
You're always using me as an example. Stop
laughing.
laughing. It's not funny.
Anyway, so let's say Kiara and then Anita are taking two different classes, but they want to find out who perform better. Let's say Kiara's data, so exam 1 score becomes 79, and class average, I'm gonna say 70. Here's the standard deviation equal to, I'm gonna say 5.6. And now Anita grade, so maybe 75. And then mean value equal to 66, or sigma equal to 6.1. Okay. So now we cannot determine their null grade and then who perform better based on null grade, who perform better, because they are taking two different classes here. But we can measure or we can guess using normal curve concept who perform better. So can you find out who got higher grade between Kiara and Anita?
Kiara.
Kiara? Why?
Because of the mean. Her X value is higher than.
But as you know, the class average also different though, right? The Kiara class
Also higher.
Class average 70.
Yeah, because the mean is higher. That means she got a higher grade. And also the standard deviation is smaller. So it's like that tall but skinny curve, right?
Oh, that's what you mean. Okay. Kiara, what do you think?
Honestly, I got lost in the middle.
You got lost?
Yeah,
Okay.
I got
Anita,
lost.
can you explain one more time what you are saying?
So like if we compare to the previous graphs, it said that the mean is higher and the standard deviation is lower. So it's like the tall and skinny graph. So Kiara should get a higher grade. But mine has a bigger standard deviation and a lower mean. So it should be further to the left. And so it should be a lower score.
Okay. Yeah, that's good explanation. What do you think, other people? Bean?
I agree.
You agree?
I agree. A is bigger grade than K. Because the average of the A is 66 and the A score is 75. It's bigger than the Kara, more than the average. How can I explain? I cannot explain it, but I feel it's A is great.
Yeah, but obviously their mean deviation, find out the mean deviation value equal to 9, right? You understand what I'm talking about? 79 minus 70 become 9. What about this?
75 minus 66.
Yeah.
It's 9.
Also 9, right? So based on mean deviation, we cannot justify because I told you there are two different classes, so we cannot justify based on number. So like Anita just mentioned that sigma value determine difference here. So like Anita mentioned that Kiara's class sigma become 5.6. So now we assume we just make their mean equal to exactly same position here. And Kiara's graph will be a little bit thinner. Something like that. Then Anita's class graph will be a little bit shorter and wider. Okay. So even though they have exactly the same mean deviation, the Kiara's is a little bit thinner, which means her position can be a little bit larger. I know it's a little bit not clear, so I will give you some technique on how to we confirm that. Okay, so that we just call the standard normal distribution. Okay, so the standard normal distribution graph, we always confirm the center value equal to 0. Okay. Before we are making center equal to mean value, right? For the standard normal case, we are making center equal to 0. So far, so good? Okay, which means now the key point is we convert each sample mean into x as 0 into the standard normal distribution. Okay. So this means we want to make, so Kiara's class 70 becomes the standard deviation here. So which means how to make a 70 to 0. Hello everyone. How to make 70 to 0.
Times 0.
Times 0, but then you are making everybody become 0. So maybe using
Minus 70.
a minus 70, right? So we are making basically, so x bar minus x bar basically. Then it will be 0. Make sense?
Yes.
Okay. And then now, so, and then last I told you that this value makes a difference between Kiara and Anita class. So you are dividing sigma, then it can be clear. Okay. So now this formula equal to z-score formula.
I'm definitely not passing this next test.
You will pass, don't worry. So z-score formula I can make. So
Professor, you moving that fast. I'm lost.
Minus x bar over sigma, or more like we are doing probability distribution, we are making x minus mu over sigma. That will be our z score. Okay, so this is just concept. And then we will talk about this one more detail, maybe the following class time. So today what we want to do, we mostly talk about how to read Z table. That's the reason I asked you to bring Z table. If not, then just I'm opening for you. 1 second, please.
Where can we find Z table?
In the blackboard.
Course material.
Blackboard.
Yeah.
Oh.
Professor, you said Z table, right?
Yeah, Z, yes.
Okay, but
Okay, so this is Z table. I'm showing to you. So Z table, so which we provided total 2 different pages. And then the first page, it shows the negative direction, the negative side here. And next page become positive side. Okay? Yeah. And then now, we need to understand what Z value represent really clearly. Okay, so I temporarily go back to our blackboard, whiteboard again. A normal curve here, we have any mean value, then we can determine 1 sigma, and negative sigma, and 2 sigma, and negative 2 sigma, like that, right?
Yeah.
And basically those value we can convert to the standard normal distance value as a 1, 2, -1, -2, like that. And then, as you know, mean become 0. So 1 means 1 standard deviation away. 2 means 2 standard deviation away from the mean. That's what this means. However, you know that the many other data exist between even 0 and 1. So that's the reason we can make maybe 0.5 here, and then 0.1 here, and 0.9 here, like that. But this table even provides a little bit more detail because we're using 100 digits, okay? So my conclusion is Z-score represent distance from the mean value, basically. As a standard way, those Z-score.
Wait, it represents what?
Distance from the mean value. Okay. That's just the definition, so you don't have to use it a lot, but if you use that definition, then it will give you a better idea. Okay. Now, do you see this Z table shade area value here? Do you see my mouse?
Yeah.
Yeah. Here. And also here. Somehow it shows that table entry Z shade area here. Table entry, the shade area here, which means each Z value indicate cumulative area from negative side to this amount of value. Okay, so did you open Z table now?
Yeah.
Okay, then let me ask you, what is the Z equal to negative 2.53?
0.5 what?
Negative 2.53.
0.0057.
Yeah. 0.0057 here, right?
Mm-hmm. Wait, I'm confused. How are you doing this? We look at the Z side, right?
So here, so negative 2.5 and then 0.03.
So it'd be 0.0057.
Yes.
Okay.
Okay, let's do one more. What will be negative 1.96?
Wait, say that again?
0.02.
Negative 1.96.
0.0250.
The 0.0250. Yes?
Yes.
Kiara,
Yes.
Carla, Kayla. Okay. Now, what is the negative 1.28?
0.1003.
Yeah, 0.1003. Yes?
Oh,
Yeah.
Sorry, I went to the bathroom. I had my AirPods in though. I was listening to you guys.
Okay.
0.1515.
Yeah, 0.1003. Yes? Okay, so a little bit harder one. What is the negative?
People don't let people listen.
What is negative 0.29?
Wait, say it again.
0.3859.
0.29.
0.3859.
Great job.
Yeah.
What about 1.28?
Hold on, where you going?
What you doing?
1.28 on the positive side, that's why I'm moving for you.
0.8997.
Yeah, 8997.
Yeah, 0.8997, right?
Yeah.
Okay, what about 2.00?
Would it be
It's 9772.
97772?
Yeah, 0.9772, right?
Yeah.
Now, what about 1.96?
96.
0.0250.
That would be 9750.
I got 9750.
9750.
Yeah, 9750. What about 2.57?
Can you repeat that?
9949.
I got 9949.
9949.
9949. That's good, right? Okay, so whatever you read, they're all on their left-hand side, okay?
Okay.
Yeah, so which means, what is the area on the left-hand side? Z equal to 1.28.
0.8997.
0.8997, right?
Yeah.
Okay, what about, so now listen carefully. This time I'm gonna make you a little bit confused. Sorry, Kiara. What about the area on the right side, 1.28?
1.28. Will that? I don't know.
0.8997.
0.8997 is on the left-hand side. I'm asking right-hand side.
Wait, say it again.
So what's the right side area?
0.8 is that number.
1.28.
Would it be negative?
There's no negative value.
Would it be
1.8888?
No, 1 minus.
Would it be
Let me check. Let me just write it for you. So we found out the
You actually have to write it down.
equal to 1.28. You read that 0.8997, right?
Yeah.
That this represents left side area.
Okay.
Then I'm asking, what about the right side area then?
1 minus this number.
0.1003.
100, yes, because 1
What the
minus
hell how you get that?
997, so 0.1003. So Kiara, do you remember the total area sum always become 1?
Yeah.
Yeah, I emphasize that, right? That's the key value. We keep on using it. So whenever we throw the 0, so 1.28, 1 minus 997, 0.1003.
0.1003.
1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 minus 997, 0.1003. 1 this area,
Yeah.
become 0.8997, then that
Okay.
area must be counterpart to 1. So that
Oh,
1
okay.
minus 0.8997. Okay?
Okay.
Okay. And now, before I give you some practice problem, it's a really challenging problem. Oh my God.
Why would you do such a thing to us?
Because you all need that between, oh my God, between z equal to, I'm gonna make it up, so I don't know the number. So
What?
negative 1.36 and z equal to 1.11. I made up, so I don't know the answer at all, okay? So find out area between z equal to negative 1.36 and then 1.11. I just drew the picture for you.
All right. So the first one I don't know, but the second one I definitely got it.
We are finding area value here, basically, between. That's the hint.
Oh, both of them. Damn.
The number has to be between those two numbers.
Yeah, basically. The thing that he coloring in pink, we gotta find like the area.
Yeah.
So don't you just multiply those two numbers?
That's a good idea, but I don't think so.
I did not go get us the answer neither.
I'm sure some of you maybe may discover the method of what to do.
What do we have to do, Professor?
Okay, I'm gonna give a hint. It's a picture. So
2 minus.
1 second.
Okay.
If you read negative 1.36, you will get this area. And if you read 1.11, then you will get this area. That's the hint.
So right side, left side.
Got
it. That the hint.
So you would do it separate and then add it?
Add it?
Subtract
Maybe
it.
subtract it.
Subtract it.
Subtract it? Yeah, I think subtraction can be a great idea.
Professor?
Yes.
Can you put that Z
Is
table,
the
please?
So what do we subtract then?
Negative 1.36 minus 1.11.
So if you subtract between z-score, then you will get very different z-score values. So I don't think it's correct.
He did it.
Bin.
Oh, how about you like,
I don't think so.
what if you add them two together and then subtract it from 1?
I don't think so. But here,
Oh
I
my
give you
God.
that's the negative 1.36. Whole thing is 1.11.
Okay. Oh, wait. 1 take away 1 negative 1.36.
No, I told you if you subtract that, then you change the z-score value. So you shouldn't do so.
Are y'all texting on here?
Venus.
I'm not, yo, y'all bugging out on this app. All right, y'all doing too much.
I don't know what to do.
Okay, so another hint. Using
Do we use the Z formula?
Not yet.
We don't understand the deviation.
Using the area values.
Okay.
Because if you read it, then you will find out each area value. That's another hint. Okay, so I'm gonna give you now answer. So read negative 1.36 and 1.11, please.
1.11. That ain't that 0.8665.
0.8665. What about negative 1.36?
See, that's the problem. I ain't have that one.
Wait, so are you getting these numbers from the
Yeah, you getting the numbers from the chart.
It's 0.0869.
0.0869?
Mm-hmm.
Okay, then now, which means this value becomes 0.0869.
Mm-hmm.
This value becomes 0.8665. So what if you subtract from here to here?
What if we what?
Subtract.
Yeah, if you subtract that.
I got negative 0.7796.
You did the opposite way. So 0.8665 minus 0.0869.
So it'll be positive 0.7796.
Yes. So basically, on this area value, you took out this much because they represent 0.0869. You know what I'm talking about?
So 0.7796. That's the missing piece.
That's the answer, basically.
That's the answer?
Yeah.
Oh, okay.
Okay.
So which means whenever you are finding between area, then you read two different z-scores and then subtract your area value.
Makes more sense.
Okay. So
yeah.
Now you are ready to practice some problem. So go to page 47. Or page 47, number 3, 4, 5, please. Okay.
3, 4, 5?
Yes.
Wait, where you put the Z chart again? Say that one more time.
It's on black.
For 3, I got 0.9131.
Yeah, I got that too, but aren't you supposed to subtract?
I don't think you're supposed to subtract.
You only subtract when it's not in the shaded area.
When it's not to the left.
Okay. When it's to the right, you have to subtract.
Yeah.
So like if you see it's the shaded areas on the left, on the right you subtract. If the shaded area is on the right, like yeah. So yeah, to the right you subtract.
What the professor at? What he wants?
So for number 4, 0.35.
Listen.
No, I think I'm looking at the wrong chart, y'all.
He just sent me the chart too.
Okay, send me the chart because I tried it on the Blackboard, but Blackboard kept logging me out.
Why you didn't say that when he just sent it to me?
Alright, so just screenshot it and send it to me.
Girl, what you think this is?
Write your email on the chat if you can't get the Blackboard, and then I'll just email it to you.
Oh, that's nice. You heard her, Naomi?
Yeah, I heard her. I'm about to do it.
Hold up. Where Kyle?
Okay. Wait, how I write it on the chat, y'all? Hold on.
No, see, look, you subtract. See, y'all confusing me. You subtract when it's to the right.
Yeah.
You're confusing me. You subtract when it's to the right because the graph automatically says to the left. So
Yeah.
what are y'all talking about? Y'all
Yeah, that's what he
confused.
said. That when you
Yeah,
have to subtract when it's on the
somebody
right, we
said,
did.
but somebody said you gotta subtract when it's to the left. You don't have to
No.
subtract when it's to the left. You subtract when it's to the right.
And when it's to the left, you
just go by the chart. You just go by the chart when it's to the left.
Okay, let's do this together and see what we're gonna get.
Finish.
136. You finished? Oh.
He said 3 to 5.
3 to what? 5?
3 to 5, yeah.
All right.
1.3.
Did you get it? I just sent the email.
0.9.
Okay, thank you.
All right, I got 0.9.
Okay, I got it.
So to the right, right? So for number 4, I would do the negative. I would do 1 minus negative 0.65, correct?
And that gives you 0.35.
No.
Wait, what?
You have to find the number of that. You have to go to a negative 0.65, and that gives you 0.2578. And then you subtract that by 1.
No. So like for negative 0.65 is 0.2578.
Yeah,
and
that's
you
what I got.
subtract that from 1.
Yeah.
And you shouldn't get negative.
You should get 0.7422.
Yeah, that's what I got.
Oh, I heard you said negative.
Oh no, she said that you subtract 1 from negative 0.465. I was trying to find the number for negative 0.65.
Oh, okay.
I did 1 minus 0.2578, right? And then you get 0.7422. Yeah.
Okay.
Where did you get the 2 point? You subtracted.
You have to look on the Z table. Go to negative 0.
So basically, you're taking the money, subtracting it from the left side, and it will give you the right side. Exactly. Wait, post that again?
Okay.
What did you guys get for 5? For Z 0?
I got 0.4382.
Me too. Because for 0, you got 5,000, right? 0.5
Yeah.
thousand.
Minus the 0.0618.
Yeah. So number 4, I got 0.2578, and I have to subtract 1
from
1
minus that number from that.
Yeah.
Okay.
Yeah.
Awesome. Thank you.
I know I'm being a pain in the ass, but say the answer for number 4 one more time.
I sent it. It's 0.7422.
Okay. Maybe we should just
left side, we don't need 1 subtract this. Just the right side, we have to use 1 subtract this number.
I think we established that already, Ben. Where you been at? We established that already.
Wait, so if you're going to the right side, that's the only time you subtract from 1, right?
Oh, I put 722. It's 422.
Thanks, Anita.
Oh, I meant I got the numbers wrong. 1 is 3, 2 is, but you guys get it, right?
Yeah.
What's wrong?
Number 5, yeah.
I got 0.2054.
For what?
For 5.
What did you get?
Point. 0.2054.
Wait, so for 0, you got 0.5000, right?
Yeah.
And
So
then
it's 0.7054 minus 0.5000 equals
what did you get for
0.2054.
154?
So this should be number, what, 5?
Yeah, I got 0.9382.
That's what I got too.
And then I subtract that from 0.5000.
Where did you get that 7054 from?
1.54, right? Did I?
1.54, yeah.
1.5. Oh, 9382. I don't know what I was looking at.
It's 1A.
Okay.
God damn it, where's
So
the professor?
he always leaves you alone for this.
We'll have to see us suffer.
How long? For how long? When he coming back? We only got like 13 minutes in this class thing.
I'm still here.
Oh.
I'm
Alright.
still here.
Okay, so let's check the answer then.
Mm.
Yeah, so what's the number 3 answer?
0.9.
0.9131.
Yes.
0.9, one second, so 1.46, right?
1.54.
Yeah.
938.
To the left.
To the left.
0.9131.
31.
31. So did you all get this answer?
Yes.
Yeah.
Okay, now
No.
to the right, z equal
I
to
got one. I got 0.9115.
How did you get that?
I didn't get that.
No.
I got 0.7422. That's the final answer.
You got 0.
and now this one to the right side, what did you get?
I got 0.5.
Professor, go over that one, because I'm confused. They confusing me.
So here, so we're gonna find out negative 0.65 on the right side, right?
Yeah.
Negative.
So negative 0.65. If you read the z-score, then you will get the area value here, right? It's this. So I think negative 0.65, 0.2578.
Yes. 578.
Yes.
Yeah.
And you
Yeah,
subtract
0.8.
1 from that.
0.2578. So because we are finding on the right side, so
Subtract 1.
1 minus 0.2578, then
Which is 0.7422.
0.22. Okay, so if you get 0.7422, then you get the correct answer.
So whenever
Now,
right side, you subtract 1.
yes, right by over subtract 1. Now,
Okay.
number 5, between, so equals
Z
0 and
ain't that like 5,000? 0.5000?
Yeah.
this one become 0.5000, right?
Yeah.
The other one is 0.618.
No, I got 0.9382.
Me
That
too.
sounds correct to me. Let me double check. So 1.54.
1.54 is 0.9382.
I
Okay,
wish
so
there was an app for this
0.9382.
table.
So you subtract from bigger to subtract then as smaller than 0.9382 minus 0.5000, which means
0.4382.
382. That will be correct answer basically. Yes.
Yes.
Okay, so I'm gonna give you homework number 1, 2, 6, 7, 8, 9, 10. Okay, so same page 47.
Wait, what? 10 look a little difficult there. What that mean?
Try first.
Stop laughing at me, y'all.
1, 2, 4, 5, 6, 7, 8, 9, 10. Okay. So that's
Okay,
your
what does
homework
symbols
question.
mean? What does symbols mean again? Greater than, less than.
Yeah.
And what's that? You know, you see the little Z in the middle of number 10?
The number 10,
C.
A,
Number 10, C.
between.
Oh, in between.
Oh, okay.
So I think you can do that. So try those questions, and then coming Monday, we will go over the questions.
So less than is to the left and greater than is to the right?
Yes,
Wow.
you are right.
Yeah, that's correct.
Yes.
Yeah. Okay.
Okay, bye.
Okay, so see you on Monday. Have a good weekend.
Thank you.
You too.
Bye.
Bye.
Bye, y'all.
Bye.
How do I leave this?